So these are the components, or these are the layers which you want to use. So we have the following. We have the following Unix shell. We have the following Unix structure command. I mean Unix structure layers. Okay. In these structure layers, something which you want to understand on this structure of the architecture, sorry, of this architecture, any type of program which is written in Unix operating system, process to the kernel layer. Okay, any program which you're going to write, which you shall write, it will go to the kernel. What is a kernel? Kernel is what? What is a kernel? We have seen the previous class. Kernel is, what is kernel? Yeah, it's a heart of operating system. Okay, that's what we have seen. It's a heart of Unix
operating system.
Yes. So the kernel means the center or origin. Okay, we mean that, okay, any program, all these layers which are going to focus on, let me give you these types of layers. Okay, you can take a note of these layers, and then I will give you the proper detail of our note. You can write this type of layers here. So these are the layers of Unix architecture. Number one, we have application program layer. Number two, we have editors or command layer. Number three, we have a kernel. Number four, we have physical or hardware layer. So write down these layers, and then we come back to the every content, each content. Okay. So this type of layers. And once you're done to write these types of layers, I will give you, because there are two questions which are important in Unix, my dears. Two questions which are important. Number one, you have to know the neat diagram of Unix component. That's proper neat diagram of Unix component. Number two, proper neat diagram of Unix architecture. Keeping in mind, Unix architecture is a set of layers that are in Unix operating system. Okay, that's a set of layers. Okay, the components are the parts which we may need to use, right? So you can write down this. Okay, this is the Unix architecture. You can draw this architecture. Okay, this Unix architecture. This is the architecture which we shall discuss now. Okay. In this architecture, we have a user application, the system calls. What is a system call? What is a system call? Yesterday, I have mentioned about the system call. That is what? For those who remember. The system call. Yesterday, I think I have mentioned about the so-called system call. Yeah, I think it is the, what is the system call? You can check from your notebook. What is the system call? From yesterday's class. Yesterday's class, was it yesterday? Yeah, yesterday class. Yesterday, no, the previous class about the component. Even yesterday I have mentioned. What a system call? What are the system call? What do we mean system calls? System call is what?
Special function.
Which does what?
System call is a special function which allows all thousands Unix commands to communicate with the kernel.
Thank you. Thank you. Excellent. So all the kernel, they're going to be communicated. I mean, the commands are going to be communicated to the kernel by using the system call. So the system call, they act as a special function. Excellent. Good. So now that's a system call which yesterday we have seen. Now we are going to see how the user application programs and the system call, the file system, the process, they are going to work together. These layers work together. Okay. This is a, as you can see on this diagram, look carefully. Look carefully. We have the system, file system, system caller here, application programmer here. We have process control here. Process is here also. processes here, which are going to look upon today. The layer, these are the layers. This is the layer, this is the layer, this is another layer, and this is another layer. Okay, this is another layer. So we are going to see one by one and see how these things works. Okay, and So we have seen that a shell is what? A shell is interface between a user and the kernel. Okay, a user and the kernel. So we shall see all the things if time permits. So now you can see now, what does it mean system calls and the library interfaces? Represents the border between user program and the kernel. Okay, why? Because it's going a special function, as we have said, which allow to communicate with the kernel or programs which a user may type. So we have the two types of system calls. Number one is a file subsystem. Number two is a process subsystem. Okay, these are going to represent the borders between the user program and the kernel, the user program and the kernel, and it has a two main system. Number one, we have file subsystem, which is used to manage the files. Allocating file spaces is missing, file space, administrating free spaces, control access to files, and retrieve data from users. Okay, this is the work of what? This is the work of file system. Okay, subsystem. Process subsystem. This, remember, these are the types of layers. Okay, this architecture. Process subsystem is responsible for process synchronization, interprocess, communication, memory management, and the process scheduling. Interprocess means updation, okay, or updating what's going on, okay, what time to update, that it happened by synchronization. Process scheduling, what time another process. What is a process? Yesterday we have seen a process is a program under execution, okay? A process is a program under execution. What is the next program to be executed? All this is taking place by the process subsystem, all right? The process subsystem, okay? So these are the system call. And I was telling you that any type of program which is operating, which is Unix operating system, has to go through kernel layer. Okay, it has to pass through kernel layer. Okay, now kernel layer, we know that the kernel layer is a center or origin of Unix operating system. Okay, now any type of program which you are going to do, which you are going to write, we can interact it through kernel. Okay, now kernel can use kernel in order to interact with these programs. We have to pass through some of the layers or the components. Number one, we have to pass through share. I will give you an illustration. Share. You remember share. This is number one. Okay. Number two, we want to pass through commands. Okay. Through commands. Through commands. Okay. Commands. And number three, we can have also other created programs. Some created programs created. This I can write here. I can write created programs. Okay. What is this? Okay. What is this? This is known as interaction. This is interaction of any program through kernel. Interaction. This is interaction of any program. You can write as I'm saying. It is interaction of any type of program, okay, in Unix through kernel. It has to go to shell, commands, or it can be created program. Okay, it can be a created program. So all these layers, all these processes, they're going to be taking place where? In Unix, Unix system, Unix OS architecture. So the hardware control, as you have seen the hardware control, this is a kernel, there's a hardware here. Okay, through hardware, this is the last one, this is hardware control. Okay, we have seen system call, file, and process. Okay, now hardware control. What does hardware control does? The hardware is responsible for handling interrupts and for communicating with the machines. Okay, we may have the hardware control. It may be like the mouse, the keyboard. You remember terminal, a terminal is made of two input output. Okay, a terminal is made of what? Display. Terminal is made of display. Okay, display. What is a display? Display is a monitor. Okay, display is also monitor, is written as a monitor. Okay, monitor, that's what happened. So monitor and what is next? And a keyboard. So these are the external output devices which are the hardwares which you may interact with. All right, so these are the components, these are the architecture of Unix, As I told you yesterday, Unix has one of the features which is known as security. Every terminal is also equal to a user. Every user has to have username and a password so that you can secure your system, so that you can be able to secure your data which are there. So for the next class, I will show you how to install Unix, okay, in your system. Okay, in your system. At this moment, let me show you how a kernel and a shell, they can work together, because the next class we shall see about the next class will be about Unix command format. Okay, Unix command format, how does Unix command format works, and the architecture of all these files. Okay, we shall see them. Now let's see the number one. So for understanding, okay, for better understanding. Did you write down? Can I give you time to write down, or I can switch to the next? Somebody say, yeah, call of voice. Yeah, it's a call of voice. Thank you, Kilan. So yes, Yuvaraj, I had mine. Okay. Okay. Did you write down? Was it fast, or what do you say? Was it fast? You need time to write down, or you saw, or you wrote down? Did you write down? How many of you did write down? Or how many of you want like a 2 minute, 1 minute to write down? Okay, so is it clear? I just want to make sure if is it clear to you all. Is it clear? Please, you can reply, so I can know whether to have the next step or to pause on this. Let me ask. Banu Prakash, okay, Yuvaraj, clear. Sina, is it clear? Hima Kumar, okay.
Yes, sir.
Okay, good. Ravania, clear. Okay, good. So now let me switch to this. I come back to this. Okay. So this is, are you able to see the screen now? Okay, good. So this is Unix shell operating system. Okay, This is Unix shell operating system which shall use. Okay. So for you, I will. What is the username? Username is, I think, is a root. I have gave as a root. Okay. Let's see. Hey, I forgot my password. Okay. Yeah. This is Unix shell programming. Welcome back to the Unix shell programming. Now you are in the lab, and I told you I want to explain to you how a shell and a kernel work together. Okay, how a shell and a kernel work together. Okay, I just want to give you a simple explanation of this one. Okay. All right. So in this one, we use something called the command prompt. Okay. We use the command prompt. No, terminals. We use the so-called terminals, which is known as a command prompt in other operating systems. In other operating systems. If this is troubling, is not working, then I will switch to the X terminal also, so that it can serve my purpose, the purpose for my program. Sometimes. So, okay. It's a small, it is small. Well, hold on, I just want to increase the format. I just want to increase the format, I mean the size of, okay, fine. Because this is too small. I don't know if you can see. I don't know if you can be able to see. Hold on, I just want to come up to this. Okay, so it's taking time. Let me not waste time in this one. Okay, let me try to minimize. Okay, try to zoom it from your phone because I'm not able to see. I want to explain how a shell and a kernel work together. Okay, I told you that we have so-called the command and utilities. The command and utilities, they're also the component which we use. One of the command which I mentioned was a CP and RM. RM means the move. Okay, the move. Let's say we have a file. Okay. Before we go to the file, we have seen yesterday something called character what? The character, what is the character type? The character type, hold on. For listing all the characters, what was that? Yeah, start characters. So like if, for example, ls means list all the characters, okay, it lists all the file which we have, okay, all file which we have. When you type ls means list, okay, ls means list. Let me, why the zoom is not, why the zoom is not happening? I just want to zoom it so you can see it clearly. Okay, let me give an example, don't mind. Then call BCA. Let me say Yuvaraj. Let me say Amarta Vani. Amruta. Let me say Ashish. Let me say Banu. Let me say Pretty. Okay. Let me say Pretty V. Let me say Surya. And so on. You can write and so on. Okay. Don't mind. I will teach you all. Okay. I will teach you all these things. Don't mind. And we do the center. So now let me say cut. Okay. BCA. So these are the names of the student which I have entered. BCA is as a file, is a file. I shall teach you how this works. Okay, don't ponder about this one. Okay, what I want to explain to you is the commands, how the kernel and the shell works together. Okay, how the kernel and the shell works together. Suppose, not suppose. Okay, let me type here, as you can see. Suppose I typed cut. Cut means to display a file. I will show you what the use of cut. Okay, cut is used to display. Or I may type RM. RM means remove. RM BCA. Press enter. So the file is gone. If I type rs, okay, star, or before I do that, I should show you how it has been created. BCA is not there. Let me create another file. Nano. Again, BCA. Hello, BCA. X. Yes, enter. Y, press enter. Okay. Now, if I say rs star, then it's going to show me what is the BCA. Are you able to see BCA? Yes. BCA is created as a file. Here, there is no BCA. Okay. On above here, I listed all the file, but there is no BCA. Here, I listed the BCA is there. Let's say I'm going to delete the file to remove RM BCA. Okay. And again, ls, then BCA is not there. Okay. BCA is not found. We have only these files. We have only this file. Okay. Now, what happened to this one? I typed, okay, let me write here so you can understand it better. I want you to understand how kernel and this shell works. Okay. How kernel and the shell works. Okay. I am going to say as I type so you can understand. I typed, okay. Okay. A programmer typed, okay. A programmer typed remove, okay, BCA. That's a file which you have created. Okay. This BCA is going to be removed. Okay. Then shell, okay. Shell searches. Shell is going to search. Shell is going to search the file store. Okay. You remember I typed first. I created the file which is called the BCA, and then the BCA was stored on home directory. What we call home directory. I will explain to you that one. Now, shell what is going to do is going to search the file store. Okay, where the file is stored. Okay, file store for the file containing the program, for the file. Ashish, you can do me a screenshot for the program containing program remove. Okay, this is LM. RM means remove file, remove. Okay, remove a particular file, okay, remove a particular file. Okay, share is going to search where this remove belongs. Where is it stored? Okay. Number two, point number two. This was a point number one. Okay, this was a point number one. Okay, point number one. Point number two. Then the shell request the kernel. Okay, shell request kernel through system call. Okay, through system calls to execute system call to execute. Okay, to execute the program RM, okay? The program on BCA. What is the file name? On file name, which is a BCA. Okay, this is point number 2. And stage number 3, when the process RM BCA, okay, has finished, okay, has finished running, okay, the shell then returns, then then the shell returns the Unix prompt, okay, Unix prompt, let's say $, or it depends by where you are, or this one, okay? So this is the relationship between how, this is point number 3, how a shell and a kernel works, okay, through use of the system architecture, one of layer code system or core file system call, which is in a file system, sub-file system, okay? So this is the stages how, how a shell and a kernel working together. Clear? So this is the illustration. This is a illustration. This is example of how a shell and a kernel work together. Okay. So one is going to search the file system called RM, and another one is going to execute, and then the process is going to be terminated by saying, okay, your process is done, because the process is a program under execution when it is executing. All right. So this is all about the system architecture. Yes, Pritias.
Sir, it is about removing the file, no, sir?
Yes.
Which is already being created.
Yes, that's called a system call. Yes, this is removing the file. Yes.
Okay. How we will create that file, sir?
Yeah, I'll explain to you how to create a file. Okay. There are ways of, there is some ways of creating a file for your curiosity, for your interest. A file is created, file creation. I will teach you, this is another classes. We have like 2 or 3 classes to run, okay? File creation in Unix, okay? There are ways of creating a file.
Sir, I thought you already thought how you created, so I asked you.
No, I have not. I'll explain to you how the file is being created. I wanted to show you through examples how a file can be removed or how file can be removed, and what theory behind a kernel and a shell, how they work together. Okay, so I'll explain to you this. Don't mind.
Okay, sir.
Okay, any question? Anyone has a question? So for the next agenda, anyone has a question? So this is, you have to know it. This you have to know how these things works, so that you can be thoroughly remove all these files we shall learn from the next class. Let me see how many classes are remaining to do this. No, yeah. Okay, that one I came to know is a meta character, that one from here. Wait, hold on. Okay. The password. You see, every terminal has a password, okay? So you can secure it. You can't do it without a password. So if I say rs star, this is star means meta character. It lists all the file, everything which I have. So for the next class, I will teach you something which is PWD. Please, PWD means present working directory. Okay, who am I? Who am I? All this we shall see. Okay, I think it is a who am I? Who am I? I am root. Who am I? I am root. Root is the main user, is a user. For you, it will say maybe pretty, it is say Alan. So we shall see this, the next class, we shall see the command format. Okay, we shall see the command format, Unix command format. For the next class, please, for your references, so you can go and prepare. Okay, next class we shall look this one. Next class, Ashish, you do me, did you take attendance? Next class, we shall see the Unix command format. Okay, we shall see the Unix command format, and okay, Unix command format, we shall see internal and external. We shall see internal and external commands. This is next agenda, and we shall see the general purpose, the general purpose, okay, the general purpose commands. Okay, commands. In this general purpose commands, we shall see so-called the calendar. Okay, the calendar. Okay, we shall see so-called date. Okay, we shall see so-called yeah, that will be that one. And the next also we shall see, the last we shall see so-called echo. Okay, yeah, that's what we shall see. Okay, so that's what we shall see for the next class. So please don't miss the next class. We shall be theory, practical work. Okay, and if time will permit, I will show you. For those who have a laptop, please let me know so that I can know if I will take extra minute to show you how to install Unix in your system. And your system has to be a bit bigger configuration. So thank you for today's class. If there's no question, then I can send you off till we meet tomorrow.
So 1 second, previous slide you put, sir.
Okay, fine. So slide or this
this thing only.
Okay.
Yeah, this one. This Unix prompt, it is will be in default. Unix prompt.
No, ma. See here. Sorry. See here. Unix prompt, see here. Where am I? So let me try to maximize. You can zoom from your phone. Let me clear this one.
Yeah.
Let's say, don't mind. All of you follow here. Okay, Pretty, class Pretty. A file name, let me call Pretty. I say my name is Pretty. My name is Pretty Rs. Okay. X, Y, enter. Now cut Pretty. Okay. Pretty. Okay. My name is Pretty. It's clear, right? It's clear. Now I'm going to remove this. If I say ls star, Pretty is here, right? You see Pretty here? Pretty is
yes,
here.
sir.
Okay. Now if I do remove rm Pretty, okay, and I do ls star meta character, Pretty is there? No Pretty.
No.
So here we are. It's known as a prompt command. Okay. This is a prompt command. Clear? Yeah. All right. So this is a prompt command. Prompt command is not a default. Is here. We are in a prompt command already. This is a prompt command. Okay. It returns.
Oh, starting it will be in prompt command.
Yeah, excellent. Yes, starting. Yes, is a prompt command. Yes.
Thank you, sir.
Welcome. Okay, then have a nice day. Time is up. So the Zoom is ending. Bye bye to you all.
Thank you, sir.
Welcome.